Welcome to this video. Here I will introduce the multiplexer circuit. It is a combinational circuit that selects digital information from one of many input line and directs it to the single output line. Let us draw a diagram. So suppose this is a multiplexer circuit. In short, it is also called MUX, MUX. So it has some inputs and a single output line. The data at the input line will be sent to the output line one by one. Here I have drawn 4 input lines I0, I1, I2 and I3. Data which are at the input ends are ready to transmit one by one. We need a dialer for that. Suppose you want to send the data at the I0 input to the output line, so you need a dialer. So this dialer connects the output with the input line. So whatever the data is at the input I0 line, that will be transmitted through this dialer and moved to the output. You can also change this dialer to some other input. So you can move it to the I1 or I2 or in I3. So this dialer will connect each of the input lines one by one and send the data at that corresponding input to the output line. Data at the input end are selected one by one and passed it to the output line. So this MUX circuit or the multiplexer circuit is also referred to as a data selector. Now, how this dialer is working, how it is selecting the input lines. For that, it requires a selector line which will select one of the input lines. So look at the bottom of the MUX. I have drawn 2 selector lines, S1 and S0. S0 and S1 are called select line or selector variable. For each combination of S1 and S0, the dialer will connect any one of the input lines one by one. That is, at different time the dialer is connecting with different inputs. So you can say that the output line is operating in a time sharing mode. Now when S1 and S0 both are in the 0 state, so the dialer will connect with the I0 input. So the data at the I0 input will be directs to the output. Next, when S1 and S0 are 0 and 1, then the dialer will connect to the I1 input. The data at the I1 will pass through the output. Similarly, when S1 and S0 are 1 and 0 respectively, it will select I2, and when both S1 and S0 are 1, it will select I3. So this process is called multiplexing. Now, so here is a multiplexer which has 2 input I0 and I1, and it has a single output line. Whatever may be the number of inputs, there will be a single output line for every multiplexer. And for the 2 input multiplexer, there will be a single selector line. I will show you next how these input lines and selector lines are related. This multiplexer can also be drawn like this. Now for a 4 input multiplexer, we require 2 selector line. And for 2 input multiplexer, we require a single selector line. So how this input line and the selector line are related? Let's see. And one thing, when a multiplexer has 2 input and 1 output, it is written as 2:1, 2:1. So for this multiplexer, it has 4 input and a single output line. You can also write this as 4:1 or 4:1 multiplexer. Now, if n is the number of input and m is the number of selector line, then they are related as n equal to 2 to the power m. You can also write like this, m equal to log 2n. Now look at this diagram. So in this multiplexer, there are 4 inputs. That means n is equal to 4. Now you have to calculate the number of selector line. So how many selector line will be required for this multiplexer? So here is my formula, m equal to log 2n. So put the value of n over here, m equal to log 2. This is 4. 4 can be written as 2 to the power 2. Now 2 will come in front. So it will become 2 dot log 2 2. Log 2 2 will become 1. So finally we will get 2. That's mean m is equal to 2. That is, we require 2 selector lines for 4 input multiplexer. Now let's see what are the advantage of multiplexer. So first I have written as it reduces number of wires. Multiplexer falls under MSI, medium scale integration circuit. So it is a IC which is available in the market. You can design combinational circuit like half adder, subtractor, etc. with this multiplexer only. If you want to design a combinational circuit with simple gates, it requires a large number of gates and wires connection also. So if you use multiplexer, the number of gates as well as the number of connections or wires will be reduced drastically. Next, reduces circuit complexity and cost. That means since the gates and wires are decreasing when we are using multiplexer, so obviously the complexity will reduced and the cost is also reduced. We can implement various combinational circuit using mux. You can implement any Boolean functions with the mux circuit only. Next, come to the different types of multiplexers. Multiplexers are available as 2:1, 4:1, 8:1, 16:1 and 32:1. 2:1 means it has a 2 input and 1 output. 4:1 means 4 input and 1 output. 8:1 means 8 input and 1 input, and so on. So for a 2:1 multiplexer, you require 1 selector line. For 4:1, you require 2 selector line. For 8:1, you require 3 selector line. For 16:1, you require 4 selector line, and for 32:1, you require 5 selector line. Let's design a 2:1 multiplexer as an example. This is my 2:1 multiplexer. It has a 2 input lines I0 and I1, and it has a single output line and a 1 selector line, and it has a enable line. That's mean when the enable line is 0, the multiplexer will not work. For any given inputs, it will give you a 0 output. And when enable is high, that's mean multiplexer is enabled. Let's draw the truth table of this 2:1 multiplexer. Look. So E is my enable line, S is the selector line, and Y is the output. When E is 0, whatever may be the value of S, whether 0 or 1, it will not transfer any input data to the output. Now, when E is in the high state, that is active state, multiplexer will work accordingly. So, for the next two condition, E is 1. At that time, when S is 0, the data at the I0 input will be passed to Y output. So I have written I0 over here. And when S is 1, it will select the I1 input, and the data of the I1 input will be directs to the Y output. So this is your truth table of the 2:1 multiplexer. So before implementing the logic diagram, let's write the Boolean expression first. So this is my Boolean expression. I have considered those rows which has high enable. So we will consider the last two rows. Now look, we are getting I0 in the output when E is 1 and S is 0. That's mean you have to write like this. Since E is 1, just simply write E, and S is 0. That's mean for the AND operation, we have to write a dot over here. And since S is 0, so just write down S bar, again dot I0. Or there is another condition where we are getting I1 in the output. So for that, just write down a plus sign, that is a OR. So we are getting I1 in the output when E is 1 and S is 1. So just simply write down E and S along with I1. Take E common from here. So within bracket, it will come S bar dot I0 plus S dot I1. Now we are going to draw the logic diagram of this 2:1 multiplexer. First, draw the selector line S. So in my expression, there are two conditions, S and S bar. So for that, you have to draw S and S bar line. So this is my S line, and since an inverter is attached with a S line, another line has been drawn, so we can treat it as a S bar line. So this is S line and this is S bar line, and it has a 2 AND gate. There are 2 AND operation is going on, one is over here and another one is over here, so you require 2 AND gate. And with the 2 AND gate E is common, so E will be connected with 2 AND gate. So when this enable line is low, the AND gate will not work, it will always give you a 0 output. When the enable line is high, so it will work according to the input and the selector line. Now in the first AND gate, there are 2 more input, that is S bar and I0. So you have to draw a connection from S bar line and I0 line. So this is the scenario. So a connection drawn from the S bar line and I0, which is completely an independent line. Then in the second AND gate, there are 2 more input, S and I1. So you have to draw connection from S and from I1 input. Both these AND gate are connected with an OR gate. So just make an OR operation with the output of these 2 AND gate and you will get the Y finally. So this is the logic diagram of 2:1 mux. Okay, then I think you have understood how to design this multiplexer, the 2:1 multiplexer. In my next video, I will show you how to design 4:1 multiplexer. Subscribe to my channel Online Technical Mentor and press the bell icon for latest update.